Okay, today we're going to learn about systems of inequalities. As we talked about in our previous lesson, anytime you have a system, you just have two or more equations that you want to solve. So if you wanted to solve this system of equations using elimination, you could just simply apply this technique right here. Multiply by a -1 on every term in the top. And that's why I go ahead and put the negative with the parentheses so that you know it's going to now be -5, positive 3y, a negative equal sign, that's a joke, and -16. But I use the joke as a means of emphasizing. Students in the past have only changed that sign, and they forgot all about the 16. All right, so that being said, add them together, and you now have -5 plus 2, which is -3x, positive 3, -3, that cancels out. And then -16 plus 10 is -6. So when you divide by -3, x is 2. That being said, put 2 back into the original equation, 2 times 2, minus 3y. I should say one of the original equations. It doesn't matter which one. 4 minus 3y equals 10. When you take away 4, -3y equals -6, so that y equals positive 6, my bad. Y equals -2. All right, so your solution is 2, -2. You can always check that by going back to the original 2 and substituting them in to verify. So that makes 10. That makes positive 6, and that indeed adds up to 16. This one is going to make 4 when you put in 2, and negative is going to be a positive 6, which is indeed 10. All right, a system of inequalities is similar, except that in this case you have two inequalities to graph, okay, to graph. So today we're going to be graphing a system of linear inequalities to determine its solution region. What is the solution to the following system? Well, start by going down to -2, just like you would graph any equation. The slope is 1/3, so up 1/3. And then, because it's not equal, it's a dashed line. So I'm going to get a nice dashed line here using my smartboard technology like that. Okay, and then I just have to position it so that I get a dashed line. There we go. Do not forget your arrow tips. The lines go on forever. Now, test 0, 0, as we've done before, by putting in 0 for y and 0 for x. Well, if you put in 0 for x, that whole thing's going to become nothing. So is 0 greater than -2? Yes, 0 is greater than any negative number. So we shade everything toward 0, 0, but I'm just going to put little arrow tips. Okay, I'm not going to shade the whole thing yet. Why? Because I have a system. There's another shade to keep in mind, and that's this second one right here. Start at positive 3, go down 2/5, and this is going to be a nice solid line. So let's get a nice solid line out of our technology here. Not good. I want a nice firm solid line. There we go. Let's see if that does it. Okay, good. Now that one's coming this way. And so let's position it right there and right here. Of course, if you had a ruler, you could just go ahead and draw the line on your graph paper. And again, don't forget your arrow tips like that and like that. And now let's test 0, 0. If I put 0 in for y, this is going to become 0 if I put in 0 for x. So is 0 less than or equal to 3? Yes, it is. It's less than 3. Some people get tripped up on the idea of, well, it's not equal. Well, the question is it one or the other? Okay, so it's definitely less. 0 is less than 3. So therefore, again, we shade towards 0, 0, but I'm just going to do that. Okay. All right, there we go. Now, with technology, I can do some real cool things here. The idea is because this solid line is shading this way forever, and the dashed line shading this way forever, they cross right in here, and that's your solution region, where they are crossing. Okay, see, I got an arrow going up on the dashed line. It's going up into this region up here, but that's not going to be part of the solution. Same with this black line up here, the solid line, I should say. It's going way down there, but I'm not going to shade way down there because it's stopping at this other line here, the dashed line. We call those boundary lines, Okay, so there's your solution. However, watch this. If I go ahead and just use two different colors, a couple of good primary colors here. Let's see, I want to get a highlighter. And for the highlighter, I want to use yellow. If I shade yellow this way, okay, and notice I'm going into the region that I shouldn't be going into. Uh-oh, you're cheating. No, I'm not. Just hang on. All right, so I'm putting all this up because I know it's shading towards 0, 0. And then if I go to the blue highlighter and from the solid line, I start shading up, look what happens. It doesn't turn blue. I don't know how good it might be showing up on the screen that you're watching, but see, you can see it's blue down there at the bottom where they don't come together, but where they come together, it's green. Okay, the green region is the solution region. Now, just to prove my point here, let me get a new pen. Got a pen, okay, we'll do a blue color there. Here's my proof of why this is a solution region. You can pick any point in here. I'll pick -2, +3, okay? -2, +3 is in the solution region. If I put in -2 for x, I get 1/3 times -2 over 1 minus 2, and that's going to be the y value. 3 is 3 greater than all of that? Well, let's find out. I hope it's obvious to you that 1/3 times -2 is simply -2/3, and -2/3 minus 2 is going to be a total of -2 2/3. Yes, 3 is greater than -2 2/3. So it's true. Now let's try -2 on this. If I have less than or equal to 2/5 and -2 for x there over 1 plus 3. The y value is 3, so is 3 less than or equal to, what's that? -4/5 plus 3. Well, -4/5 is like -0.8, which is like -80 cents. So if I add -80 cents to 3, I'm going to have 2.8. Is 3 less than that? No, it's not. Then what mistake did I make? I made a mistake on my video. That's okay. That's a plus, negative times negative. If you caught that, leave me a comment saying something like, come on, Mr. Eisenberg. All right, 3 and 4/5 is 3.8. So 3 is not less than 3.8, okay? By the way, I didn't make that mistake on purpose. I double checked because I knew this had to work, assuming my work was done correctly. All right, but because it's done correctly, you get two expressions up here, the -3 and that greater, and the 3 less than that are true. All right, do this, pause the video at this point, and go ahead and try this one on your own. Welcome back. Let's go ahead and see what happens here. You start at -2. Your slope says go up 3 over 1. That's for graphing this one. It's a solid line. I'll go ahead and just draw it in this time. We test 0, 0. If I put in 0 for y greater than or equal to -2, because that's going to make all that a 0. 0 is greater than -2, so it shades toward. Let me go ahead and get that marker out again. Let's see what happens here. Here we go. It shades towards 0, 0. It includes 0, 0 in its solution, okay, in its solution region. Okay, go back here, and let me get a different pen. There we go. And let's graph starting up. Uh-oh, I got to divide by 4. Okay, all right, here we go. Got to do a little work on this one. Less than -1/2 x plus 3. So we start at 3 this time. Go down 1 over 2, go down 1 over 2, go down 1 over 2. It's a dashed line this time because it's not actually equal. So we got a dashed line going through those right here. Arrow, arrow. And let's test it. Now you can test your original or the one that you modified. As long as you modified it correctly, it should be okay. It will be okay. 0 is less than 3. That's true. So this also shades towards 0, 0. So let me get out my blue highlighter and shade everything towards 0, 0 that way. Okay, like that, like that, like that. And as you can see, okay, some of that shaded region is blue. Other parts of that shaded region is green. The green is the solution region, okay? But it's blue over here. I know, watch this. I have to just shade more yellow, that's all. Okay, because I'm shading that yellow forever that way, okay? So where they come together forever, 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 that's your solution region. Again, if you want to pause the video now that you can see the two equations, inequalities again, now that you can see them again, test by putting in any point. You could even test a point over here. Over here it shouldn't work for either. Over here it should just work for the one that we shaded blue. All right, now here it gets a little more complicated. In fact, this last one, let me take you to this one. This is the most complicated of all of them that I've gave you. Go ahead and pause the video and start working this out, and I'll be back with you when you're done. Okay, welcome back. Now, on this one, we're going to start at -3. We're going to go up 1 over 4. It's a dashed line again. Let me go ahead and for this one, because it's a pretty complicated one here, to use the technology. Ooh, that's pretty cool, blue line. Hey, let's go back though, because I'm not getting a nice straight line. Straight line, and there we go. Okay, all right, now set that on here. Doot, doot, doot. Yes, you get free sound effects with this video presentation. All right, oh, come on, come on. All right, there we go. Again, don't forget those arrow tips, please, please. All right, now the next one, oh, we didn't shade it. Okay, all right, let's figure out the shader. Okay, go back to the pen, and what we're gonna do is ask ourselves, is 0 less than -3? Now, some of you are still getting confused about that. 0, 0 is right here. It's off the line, okay? So when you put in 0, 0, we're saying put in 0 for x and put in 0 for y. All right, so if I put 0 in for x, I just get a -3. So is 0 less than -3? No. 0 is greater than -3. 0 is greater than any negative number. So this is going to shade away from 0, 0. So here's my little arrows going down like I talked about earlier. Okay. I just know it's shading in that direction. Once I find the shades of the other two, I can go ahead and put them all together. All right, let's take that out of there. And now let's go to the next one, which is less than or equal to 5. Well, x equaling 5 is a vertical line going through 5 forever like that. Okay, don't forget the arrow tips. And test it by testing 0, 0. But there's only one 0. I know, but look, put in the x for the 0. Is 0 less than or equal to 5? Yes, 0 is less than 5. So this one shades toward 0, 0. Forever and ever, amen. Just like Randy Travis. Okay, go that way, go that way, go that way. All right, now the last one we're going to go ahead and test is, we're going to figure out how to graph this next one. You could use the intercepts, but I'm going to go ahead and just remind you, if you write it in slope-intercept form, don't forget something. You end up with -4y is greater than -3x plus 8. Now, when you divide the -4, okay, you flip the inequality around. So, new color so you can see it good. Y, when I cancel that out, is now less than, two negatives make a positive, 3/4 x, and 8 divided by -4 is a -2, okay? So that's what it changes to when you write it in slope-intercept form. And go to -2 now, right there. Your slope says up 3/4, and we want a dashed line again for this one. So let's find a dashed line down here. Okay, grab that one, and there we are. And now it's going like this. So let's get that placed on there. Right here and right here. I have to stretch this out a little bit. It's going pretty far down in there. Okay, so boom, far down into my graph here. Here we go. Okay, like that and like that. All right, now let's test the putting in 0, 0. Last time I tested it by using the one that I changed. You can also test it, though, just by simply using the original one. If I put in 0 there and 0 there for y, okay, if my x and y's are 0, 0 greater than 8? No, 0 is not greater than 8. So this does not shade toward 0, 0. So it's shading away from 0, 0. Like that, like that, like that, like that. Keep going, keep going, keep going. Now, you're going to have to visualize this. You've got arrows coming this way from the solid line there, coming down this way from that first one, and from the last one, whose arrow tips I forgot but just put in, they're coming this way. So where they're all meeting, they're meeting together at this section right here. You can see the arrows there. Underneath that one, and stopping on this line right there. We call them the boundary lines, okay? So every part of the line is satisfied. I should say instead, every part of each direction that the line shades is satisfied. And you can see it now that I've got it highlighted. See it pretty good. You've got the arrows there, 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 and then these ones coming up from the top one, and these ones coming from the side. So if I erase all this, if you want to go ahead and now pause the video to check all 3 of those by selecting a coordinate, okay? Select a coordinate anywhere in there. Can't get a coordinate. Here we go. All right. Come on. Need the new pen again. Boom, boom, right there. If I select something like 1 and -4, if I select that, it will satisfy all 3 of those. It will make all 3 of them true. All right, hope you've enjoyed this. If you're one of my students, this is the homework, so please copy the homework down. And as always, make it a great day.